Ready? Mm-hmm. Yeah? All right, so here we're looking at a slice of pie, sort of, and this is going to be then a cross-section of the diaphysis of a long bone. So again, the cross-section of a long bone, so if you want to think of this, this is the compact bone that's around the diaphysis, which is the shaft then of the long bone. The different parts that we're going to have then to this diaphysis of a long bone is the outside is going to be lined with a dense regular connective tissue, which is called the periosteum. The periosteum stays attached, firmly attached to the underlying osseous tissue or bone with these white collagen fibers that are going to be then the Sharpey's fibers or perforating fibers, okay? That's what keeps it in place. We're going to have many blood vessels that are coming. Those are going to be then, the blood vessels are going to run the entire length of that periosteum, so that when they're there, they're called the periosteal blood vessels. And then occasionally they're going to come into the bone, and they're going to then form these horizontal tubes of blood vessels going from the outside of the bone to the inside of the bone. And those that go horizontally are called the, what are they called? The perforating or Volkmann's canals, okay? So the blood vessel comes in, and then it's going to go up and down in the central canal, right? Of the central canal of each osteon. So an osteon is the central canal plus all of its concentric lamella, okay? So those are going to be those types of things. In that central canal, we will not only see an artery in red, a blue vein, and a nerve. So that's why when this fractures, it hurts quite a bit. So the osteon then is made up of the central canal and the concentric lamella. There are 3 different types of lamella. The lamella are going to be concentric when they have a common center, circumferential when they're running around the entire circumference of the bone, or interstitial like these lines there or these lines there, which are remnants of old osteons that are going to connect between one osteon and the next. So again, 3 types of lamella: concentric, interstitial, circumferential. Did I say that right? I hope so. Okay. Within the concentric lamella, you can see then the lamella themselves are made up of both organic and inorganic matter. Okay. Bone is a connective tissue. The cells that we see at this point are going to be these cells that look like spiders. These are the osteocytes. These osteocytes are going to be encased in these little holes, which are the lacuna. And they're going to have these cellular processes that come out so that the osteocytes from one layer, one lamella, communicate with the next one, that communicate with the next one, that communicate with the next one, and now can get their blood supply and their nutrients directly. And they don't have to rely on diffusion through this, hard bone. So these are then the osteocytes. The holes there are the lamella. These cellular processes are going to pass between one lacuna and the next, and I said lamella, I meant lacuna, between one lacuna and the next through these little canals, and those are called canaliculi that are going to connect then each one. These osteocytes are the ones that when they were young, they're lining this inner lining. So the outer lining was called the periosteum. The inner lining is called the endosteum, okay? This endosteum is going to have spongy bone, and what's going to happen is when it forms new bone, it's going to envelope and form a new central canal. It's going to catch a blood vessel, and now it's going to become a new osteon or Haversian system. And now each one then so lining here I've got endosteum, and lining the central canal I have endosteum. That has the osteoblasts. When the osteoblasts have enough calcium and they get a Q, they're going to form a new lamella. So the younger lamellas are on the inside, the older lamellas on the outside. When they get that cue, what do? The first thing they do is they lay down collagen fibers, which is the organic part of bone. So the collagen fibers are going to be laid down in one, kind of like a corkscrew, okay? And they're going to be laid in one lamella clockwise, and the next lamella counterclockwise. And have you guys ever made rock candy? No, because I didn't even get an acknowledgement of what rock candy is. So rock candy is, when you have like a stick and there's like sugar precipitated on it? Mm-hmm. Well, one of the processes when you do chemistry, you'll see that if you put a string in a very high concentrated glucose or whatever solution, they will tend to stick and precipitate on that string. So that's exactly what the human body is doing. It lays down the string, it's a collagen fiber, and now that osteoblast at this point concentrates the calcium phosphate and it precipitates onto that string, which was the collagen fiber. So then you've got then those types of structures, okay? So central canal, osteon, circumferential lamella, periosteum, periosteal blood vessels, perforating or Sharpey's fibers, endosteum, perforating Volkmann's canal, spongy bone. So there's all spongy bone lining the inside here. That spongy bone is the one that's going to be lined with the endosteum. All that we see here is compact bone. The vein, the nerve, the artery. The canaliculus is the singular for the tube that connects the two lacuna. Osteocyte, lacuna, central canal, lamella. And I think that's labeled everybody.